There is another method in solving for the general solution of exact equations, and this is through integrating and deriving the term of your choice. Learn about it here in Engineering Math 5. As you recall, the standard form of an exact differential equation is mdx plus ndy. We also discussed in the previous video that when we denote f as the general solution and we integrate either m or n with respect to their derivatives, we get the integral in terms of x and y and a constant in terms of the opposite variable. So the integral of m dx will be a function of x and y plus a constant in terms of y. And that will be similar with the integral of n dy as a function of x and y plus a constant in terms of x. The alternate solution will still start with the check of exactness, where one can continue by solving f of either m term or n term. You don't need to look for f of both terms. Then derive the solution with respect to the other variable and equate it with the other term, then simplify the general solution. Example number 1. Determine the general solution of the quantity 2x cubed minus xy squared minus 2y plus 3 multiplied by dx minus the quantity of x squared y plus 2x multiplied by dy is equal to 0. This is the same example discussed in the previous video, but using the conventional method. The test for exactness will start with taking the partial derivatives of both the terms and comparing them, so the partial derivative of m with respect to y turned out to be negative 2x y minus 2, which is the same as the partial derivative of n with respect to x, making the function an exact DE. Now let's solve the general solution. By checking both the terms, it seems like n is easier to work with. Thus f will be the integral of n, which is negative of the quantity x squared y plus 2x times dy. Since we are working with dy, the variable x will be taken as constant. So the integral of x squared y will be x squared, the constant, and y squared over 2, the integral of y. The second term, negative 2x, will be integrated as negative 2xy, then add the arbitrary constant, which is in terms of x. Then simplify the equation. If we derive the general solution of n with respect to x, this should be equal to m. How do we determine which variable the solution will be differentiated? It is shown from the constant. Take note that the variable is in terms of x, so we derive the n solution with respect to x. In case you also remember, we integrated with respect to dy, so the next step is to differentiate it with the x. And since we are differentiating the function with x, the variable y will be constant, so negative x squared y squared all over 2 will be differentiated as negative y squared over 2, the constant, multiplied by the derivative of x squared, which is 2x. Next is negative 2xy, which is the second term differentiated with respect to x, so negative 2y will be considered as a constant and the derivative of x is 1. Lastly, the derivative of the constant will be taken as prime of the constant, and all these will be equated with m, or the other term, which is 2x cubed minus xy squared less 2y plus 3. So we can simplify the equation and cancel out similar terms, which will leave us with the prime of the constant being equal to 2x cubed plus 3. Remember that our general solution includes only c and not c prime, so we need to integrate c prime again. So 2x cubed plus 3 will be integrated as 2 times x to the fourth all over 4 plus 3x, which can be simplified as x to the fourth all over 2 plus 3x. So going back to the general solution using n, plug in the function for the constant. And we can get the general solution for the dE as x to the fourth power all over 2 less x squared y squared all over 2 minus 2xy plus 3x is equal to c. With the same example, what if we choose to take the general solution using m instead of n? Let's start by integrating the function m, which is with dx. So we get f as x to the fourth power all over 2 minus x squared y squared all over 2 minus 2xy plus 3x plus the constant in terms of y. Next is equate the n term with the solved f after looking for its derivative, and this will be with respect to y, so all the x variables will be taken as constant. So the first term x to the fourth power over 2 is a constant and its derivative will be 0. The second term will be differentiated as the constant x squared over 2 multiplied by 2y. The third term negative 2xy will be differentiated as negative 2x. And the derivative of 3x is 0. Then lastly, the constant will be differentiated as c prime. And all will be equated to n, which is negative x squared y minus 2x. Then simplify the equation by cancelling similar terms, giving c prime as 0. C is taken by integrating c prime, which is still 0. Go back to the solution taken from m earlier and then plug in the constant, which is 0. So we get the general solution of the dE. We have the same solution from the one solved earlier using the function. Let's try example 2. Solve the equation 3x times the quantity of xy minus 2 times dx plus the quantity of x cubed plus 2y times dy is equal to 0, and start by checking TFE. The partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, which is 3x squared, so it is an exact dE. This time we start by integrating m dx to have the general solution, so we integrate the quantity of 3x squared y minus 6x times dx, and we end with f as x cubed y minus 3x squared plus the constant. Take note that the constant is in terms of y. Next is to differentiate the solution with respect to y, and then equate it with n. The derivative of x cubed y will be x cubed times 1. The derivative of negative 3x squared is 0, as we are deriving with respect to y. And the derivative of c will be c prime. Everything will be equated with x cubed plus 2y. So simplify the equation and cancel out x cubed from both ends, leaving c prime as 2y. Integrate c prime to find c, and that would be c as y squared. So the general solution f is taken as x cubed times y minus 3x squared plus the constant, where c is solved as y squared. Then we get the final general solution as x cubed y minus 3x squared plus y squared is equal to c. Now let's look for the general solution using n. F is the integral of n dy, and we get x cubed y plus y squared plus the constant in terms of x. Next step is to determine the constant, and that is by deriving f with respect to x and equate it with m. So the derivative of x cubed y with respect to x is the constant y multiplied by 3x squared. The derivative of y squared with respect to x is 0, and the derivative of c will be c prime, and they are equated to 3x squared y minus 6x. Then simplify by canceling similar terms, so we get c prime as negative 6x. We continue by integrating c prime to have c. So the integral of negative 6x is negative 6 multiplied by x squared over 2, which can be simplified as negative 3x squared. Knowing what c is, we can get back to the original solution of f and plug in c, so we get x cubed y minus 3x squared plus y squared is equal to c.